Hi, and welcome to this quick how to help video on multiplying out brackets when they contain surds. So I'll get straight into it so you can see what I'm talking about. Let's say we've got 5 plus root 27 in one bracket and 3 minus root 27 in the other bracket. We can simplify that. The brackets themselves should feel very, very familiar. We are expanding brackets that look like this all the time, very, very confidently. And we are going to apply the exact same method, the exact same principles to this style of question. It just happens to have a surd instead of a variable, instead of a letter. So I'm going to use my crab's claw, which is the method that I've used in all my videos. So 5 times 3 is 15. 5 times root 27 is 5 root 27, but obviously I've got to spot the negative there and include that in my answer. I've got a positive and a negative. Okay, I've got 3 times root 27, so that's plus 3 root 27. And then I've got root 27 times root 27, gets rid of the root. We saw that in the last video. And remember, I've got a plus being multiplied to a minus. So we've got a minus going in there. So just a quick recap. If I've got root 27 and I'm timesing it by itself, then this gets cancelled off. And that is why I've got that 27 left here. I then just really look at the numbers that I've got. So I've got 15 here and I've got minus 27 coming out there. So tidying that up gives me minus 12. And then this middle section, my root 27 section, I'm at minus 5 and I'm adding 3. So I've got minus 5 root 27s. I'm going to add 3 root 27s and it's going to leave me at minus 2 root 27. All right. And again, I'm just going to give you a little bit there in case that was confusing to you. If I'd given you minus 5x plus 3x, you'd say I'm at minus 5, I add 3, I'm at minus 2x. The only thing that's different between this and this is instead of using an x, I've used root 27. That's the only difference. So I've got 5 lots of those, 3 lots of those, but they're negative, etc., etc. Okay, so hopefully that helps. Once I've expanded, I must then start thinking about, is that my final answer? As with fractions, surds will always cancel, and we should always be looking to put it in its simplest form. And I can see really at a glance that root 27 is in the 9 times table. 9 is a square number, so this is going to split out for me. So I'm going to split my root 27 into root 9 and root 3. That's obviously going to give me 3. So I've got my minus 2 times my 3 times by my root 3, because that root 3 isn't going to go any further than that. And then my final answer is minus 12. Minus 2 times minus 3 is minus 6 root 3. And this skill of crab's claw is actually quite an important one when it comes to rationalizing the denominator. So you could just be asked this as a general question in an exam, and you're just showing that you can apply the skills of crab's claw to something that looks a little bit different. But as I say, we do use it when it comes to rationalizing the denominator, which is going to be our next video. But before we move on, I want to show you one last bracket that does feed in to the rationalizing denominators. I can't talk. Rationalizing the denominator as well. So I have got 2 plus root 7, and then I've got 2 minus root 7. Now, watch what happens when I expand this. 2 times 2 is 2. 2 times negative root 7 is negative 2 root 7. Root 7 times 2 is 2 root 7. And then root 7 times negative root 7 is minus 7. Negative and a positive makes it negative, and the root is cancelled out. Okay, so when I do the numbers, which I've got 2 and -7, that is going to give me -5. And when I look at my central bit here, this says I am at -2, and then I'm going to add 2. Well, if I'm at -2 and then I add 2, I'm at 0. I've actually cancelled out that middle section and they're gone. And this is a technique called the difference of two squares. And what it's actually doing is it's helping us completely eliminate the surd altogether. The difference between the two brackets hopefully does stand out. I've got a positive in here and a negative in here. That's creating that negative and positive middle and creates that cancelling effect. And as I say, it's called the difference of two squares. And we use it to help us when we're rationalizing a denominator in surds. Okay, so that pretty much is applying the crab's claw method when you've been given surds inside the bracket. And I hope that you found that useful.